Hey everyone, let's derive the canonical form of the discrete logistic equation. Remember, the canonical form means that we're going to write this in this form. So instead of n of t plus 1 and n of t, we're going to have some constants multiplied it. Here's how we're going to simplify. First off, might make sense to multiply the stuff in the parentheses. Keep that n of t on the outside because that looks okay. So we're going to distribute the r there and there. And we're going to get this. Okay. So that's what we did right there. Next up, I noticed that with the canonical form, I really want to have 1 for the parentheses, but instead I have 1 plus r as my constant, right, as my non-n of t term. So it might not look so nice, maybe it's a little counterintuitive, but I'm going to factor that out. So I'm going to get 1 plus r n of t times, and then I've got this 1 minus r, and then this I have to divide by r plus 1, because I factored it out of that term, right? When you factor something out like that, it has to come from each term that you're adding or subtracting. Okay. So now at this point, I notice that I have a 1 minus this schmutz. And that kind of looks like 1 minus that schmutz. So maybe at that point I say, well, wait a minute. Maybe that could be my x of t? So then in that case, I would need to make my other n of t's have the coefficient r over r plus 1 times k. So let's go about doing that. So let's say we're going to divide by r plus 1. I gotta say, maybe divide by r plus 1 times k, and multiply by r. And let's see what this gets, right? We're going to do this to both sides, so we're going to get r over r plus 1 times k, n of t plus 1, equals, well, now let's see if we do that to the other side. I guess we're going to get, I'm going to keep the 1 plus r, actually, right? That'll be my r, right? I'm going to get 1 plus r times r over 1 plus r. Oh, no, I guess I'm calling it. 1 plus r and r plus 1 are the same thing, right? Yes, I'm going to call it. So 1 plus r k n of t, 1 minus r of, and I'm just going to call this 1 plus r. K down there, n of t. Okay, now of course we note that these things cancel, but I actually don't want them to, because this is actually my lowercase r, right? That's going to be my r. This right here is my x of t plus 1. This right here is my r. This right here is my x of t. And then this is my 1 minus x of t. Okay? Where I'm going to let x of t equal r over 1 plus r k n of t, and r, little r, I should say, equals 1 plus big R. Okay, and remember, this is nice. This is called canonical form. I know it looks a little complicated like this, but I hope you agree that it does look a bit simpler like that. And that is nice because the overall form of the equation is, I think, easier to look at and work with, I'm going to say. Here's another nice thing. Instead of worrying about two variables, r and k, we have only one constant, r. And last but not least, the variable x of t is dimensionless, which means that x of t stays the same regardless of the units used. And remember, for population, that's very important because we might change it to singles or tens or hundreds or thousands or millions of units, right? Especially if we're talking about bacteria or even people these days, right? Dimensionless doesn't care. The shape of the graph won't change. Okay? So that's how you get the canonical form. And just to point out, as we've seen, as we saw in class, the shape of the canonical form graph and the shape of the regular graph are the same. The difference is that x of t is between 0 and 1 instead of, 0 and k. That's the scale. Okay? Thanks for watching.